Hello friends, welcome to Odesh Academy. Friends, today we are going to learn about center of mass. This is a very important lesson and I request you to kindly pay close attention to this. This is a very simple lesson and it has extensive use in physics. Please look into the picture which is shown on your screen. You can see that there are two masses, M1 and M2. The M1 mass is located at the distance x1 from the origin or from the center, and the mass M2 is located at a distance x2 from the center. Now we have to find out the value of the center of mass. So the center of mass in this case will be the point C, which is calculated by the following formula, that is x is equal to m1 x1 plus m2 x2 divided by m1 plus m2. If m1 is equal to m2, then we can see that the center of mass will be located at a distance x equal to x1 plus x2 divided by 2. Now that was the case when there were only two particles. If there are multiple particles, n number of particles, then also we can find out the center of mass. So in that situation, if we have n particles whose masses are m1, m2 and like that mn respectively along a straight line on x-axis, then by definition the position of the center of mass of the system of the particle can be given by x is equal to m1 x1 plus m2 x2 plus like that it will go up to mn xn divided by m1 plus m2 plus m3 plus mn. So we can summarize that and write that x is equal to sigma of mixi divided by sigma of mi, where x1, x2 and xn are the distances of the particle from the origin. X is also measured from the same origin and the symbol sigma denotes the summation, in this case over n particles, and the sum sigma mi will be equal to the total mass of the system. So just like we have calculated the center of mass on x plane, we can calculate for y plane and we can calculate for z plane. For example, if there are three particles m1, m2, m3 and they are located at distance x1, x2, x3, then x will be equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus x3. In the same way, if we take the y coordinate of that, then the y component of that will be equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. And therefore what happens that if m1, m2, m3 are same, that is equal to m, in that situation we can see that x will be equal to x1 plus x2 plus x3 divided by 3 and y will be equal to y1 plus y2 plus y3 divided by 3. Now let us find out the general equation of the center of mass in the x, y, z plane, that is in the three-dimensional plane. In that situation, as we have already derived that x will be equal to sigma of mixi divided by m. Similarly, y will be equal to miyi divided by m and z will be equal to sigma mizi divided by m, where m, that is the capital M, is the total mass and that can be written as sigma of mi. We know the coordinate of the x, y, z in the three-dimensional plane. So if we are given the x, y, z coordinate of different masses, using this formula we can calculate what is going to be the center of mass and its coordinate will be capital X, capital Y, capital Z. Now the three equations which we have derived, that is about capital X, capital Y and capital Z, we can summarize that and we can write that as capital R, that is a vector, will be equal to xi plus yj plus zk, where the position vector Ri will be equal to xii, yij plus zik. And then we can summarize the whole equation as the vector R, that will be equal to sigma of mi divided by m, where m is the total mass of the particles. Sometimes what happens that these masses are not discrete in nature, but they are continuous, and they are continuously spread over a particular distance. In that situation, what happens that we will divide those masses into very small segments, and so that the n will be tending to infinite and the masses will be equal to delta mi. When this delta mi become very small, then sigma of delta mi can be written as integration of dm, and that will be equal to capital M, that is the mass of the particle or the system. Then we can write that sigma delta mi multiplied by xi can be summarized as integration of x dm. And similarly, the sigma of delta mi yi will be equal to integration of y dm, and sigma of delta mi zi will be equal to integration of z dm. Now, as we know that here m will become the total mass of the body, and in this case the coordinate of the center of mass will be equal to x will be equal to 1 upon capital M integration of x dm, y will be equal to 1 upon capital M integration of y dm, and z will be equal to 1 upon capital M integration of z dm. And the vector expression equivalent to these three scalar expression can be written as vector r, that will be equal to 1 upon capital M integration of r dm. So friends, today we have learned about the center of mass, how we calculate the center of mass for different particles, and how we calculate the center of mass for a continuous particle by using the integration. So I hope that you have understood the concepts better. We will be solving some problem in the next lesson to give you a total understanding of the topic. Thank you very much for watching this lesson.